Hello everyone, in today's video I'm going to show you how to do the problems in today's homework. I will completely do the first problem, the other three are up to you. So for this you might want to have today's notes next to you just for additional help. We're going to be doing the distance formula quite a bit, and then on top of that we're going to use these top boxes here for our conclusion. So it says determine whether quadrilateral ABCD is a parallelogram. So we're going to need to find the lengths of all four of these sides. Once we do that, if the opposite sides are congruent, it's a parallelogram. If the opposite sides are not congruent, then it's not a parallelogram. So the conclusion is very straightforward, but it's quite a bit of work to get these sides. So before we can use the distance formula, which is at the bottom here, we are going to need to find out what these points are. We have to read them directly off the graph. So point A, it is -6, 2. Remember that's x, and then you read the y. D is -2, 8. C is 4, 2. And B is 0, -4. You got to be careful when it's on the axes. We didn't go anywhere on the x-axis, so 0, then we went down 4. So those are our 4 points. From here, we need to find the lengths of all four sides, starting with AD. So we're going to find the length of AD, in other words, the distance between points A and D. And again, for that, we will need the distance formula. I'm going to grab another one of these to lay on top so that I can have the distance formula in view at all times. So I'm just following this formula. And I need AD. So I'm using points A and D. I'm going to write those down. A is -6, 2. And D is -2, 8. Make sure you write your points down correctly. Obviously, if you write down the wrong numbers, you're going to mess up your whole problem. Next, we label our points because we need to figure out which ones are the x's and which ones are the y's and where they go. So, do it like this. x1, y1, x2, y2. Then we plug these into the formula. I'm going to copy this exactly as we see it, and I'm only replacing the x's and the y's. D equals the square root. I'm going to finish my square root later. Parenthesis. x1 is -6, minus, that's always there, x2 is -2, in this case I'll put that in parentheses, and then I need one more parenthesis to close off the outside parentheses, squared, plus y1 is 2, minus y2 is 8, parenthesis, squared, and then I'll finish my square root symbol. There's my setup. Now I just have to simplify until I get to just one number. First, I like to just figure out what numbers inside the parentheses. So I have -6 minus -2. Since I have two negatives in a row here, two minuses, that becomes a plus plus. So now I have -6 plus 2, which is -4 squared, plus 2 minus 8, that's -6 squared. Next, I square the numbers. If you're putting this in a calculator and it's one of these fancy ones like this one here, make sure you use parentheses. Type it in just as you see it here. You drop the parentheses, you'll get an incorrect answer. -4 squared should give you a positive 16. It's positive because a negative times a negative is still positive. Plus -6 squared is positive 36. All I have left to do is to add these together. 16 and 36 give you 52. So my answer is the square root of 52. I'm going to write that in the blank here. I know that if I put this in the calculator, I'm going to get a very ugly decimal, so I don't want to mess with that. I'm going to leave it like this. If you like decimals, put it in the calculator and round however you like. Just be careful with that. But I'm going to leave it like this. Additionally, I'm going to put this in my picture so when I have all four, I have them all on the graph. It's very easy to see what type of shape I have here, whether it's a parallelogram or not. So I've got AD, it's this segment here, is the square root of 52. So I know that when I go to find BC, if it's not also the square root of 52, I don't have a parallelogram. Okay, this right here that we just did, this is the process. Now you repeat it 3 more times. I know that seems like a lot of work, but I promise you, you genuinely get faster at this with practice. If I'm going quickly, I can actually do these in under a minute, each one. So, like I said, with practice, you really do get faster. You'll surprise yourself. Okay, second, we are doing DC. So let's look at our graph here. D is -2, 8. I'm going to write my points down. C is 4, 2. Label x1, y1, x2, y2. Plug into your formula. D equals the square root, parenthesis. I'm going to bring this into shot here so you can see it the whole time. X1 is -2 minus x2 is 4 squared plus y1 is 8 minus y2 is 2 squared. Closing off my square root. Next, I just get my numbers in parentheses. I am not squaring yet. I recommend you do this one step at a time. I know it's tedious, but that's how you avoid mistakes. -2 minus 4, that's -6. If you need a calculator for that, that's quite all right. 8 minus 2 is just 6. Now I square these. -6 squared is a positive 36, plus 6 squared is obviously also going to be 36. Add those together, you get the square root of 72. Again, I already know this isn't a perfect square, but if you aren't sure, put it in the calculator. If you get a whole number, then you just write that whole number. But if you get a decimal, personally, I like to leave it like this. If you prefer decimals, you can use a decimal. So DC is the square root of 72. In my picture here, that's this segment. So the square root of 72 goes right here. All right, we are halfway done. Oh, I need to uncover these so I can get my points real quick. CB, C is 4, 2. And B is 0, -4. Step 1, we label x1, y1, x2, y2. You'll know if you forget to label because if you try to jump in and just use the formula, you'll realize, oh, I don't know where to put my numbers yet. So, very easy thing to do. Okay. Now we put in the formula. D equals the square root. X1 is 4 minus x2 is 0 squared plus y1 is 2 minus y2 is -4. I'll put that in parentheses. Squared. Close off the square root. D equals the square root. 4 minus 0 is just 4 squared plus 2 minus -4. This 2 minuses in a row becomes a plus. So now I just have 2 plus 4, which is 6. And I'm squaring it. D equals the square root. 4 squared is 16, plus 6 squared is 36. And that gives me the square root of 52. So CB is the square root of 52. So now I'll come here to my graph. CB is the segment here. So then I'm going to write the square root of 52 in for that. This is looking really promising so far because I have one pair of congruent sides. So if I get the square root of 72 here, then this is a parallelogram. If I get something different, one, I'd probably check my work just to make sure I'm okay and that I'm correct. And two, I could then say, all right, this is actually not a parallelogram. Last one, BA, we need to write down our points. B, I have the graph out of shot here. 0, -4, and A is -6, 2. B, 0, -4, A is -6, 2, which matches what I wrote down here. So we are golden on that. First and foremost, we label x1, y1, x2, y2. I'm going to bring the distance formula in here so we can see it. Then we plug it in. D equals the square root. X1 is 0 minus x2 is -6. I'll put that in parentheses. Squared plus y1 is -4 minus, that minus is always there, y2 is 2 squared. Don't be tempted to change this into a plus right out of the gate, because while that is correct, there are times you're going to, out of habit, do that, and then it messes up your formula, and you'll do it when you're not supposed to. So always write it out exactly as you're supposed to with the formula, then you can start figuring out what everything is. These are just suggestions to keep you from making mistakes. 0 minus -6. Again, we've got that minus going on here, so that becomes a plus when we got 2 in a row. That becomes 6 squared plus -4 minus 2, that's -6 squared. Now I have 6 squared, which is 36, plus -6 squared, still 36. This being negative has nothing to do, it doesn't change this answer at all. So negative times a negative is still positive. Add these together and you get 72. If you need a calculator for any portion of this video that I haven't used one, feel free to use one. One, I've done these problems quite a few times today. Believe it or not, I do this pretty much every period. And 2, I'm obviously pretty decent at math, being that this is my job. So don't feel like you can't use a calculator just because I'm not using one. Finally, BA is the square root of 72. So then I just go up here and I fill that in here. Square root of 72. For the last step of this video, or this problem I should say, we look at our pair of our quadrilateral, I should say, and determine, is this a parallelogram, is it not? Back to our notes real quick. If you remember, the criteria to determine this is that opposite sides are congruent. So if you get a yes, the opposites are congruent, you're going to say that and then state that it's a parallelogram. If you get different numbers on opposite sides, then they are not congruent, and it's not a parallelogram. Here we've got these two sides, our opposites are both the square root of 52, and these two sides are both the square root of 72. So this is a parallelogram. For the explanation at the bottom, I know that when you ask someone to explain their work, when you ask a student to explain their work, sometimes that's a pretty scary thing to ask of you guys. But actually, what we're asking you to write is not bad at all. I am just asking you to write down the 2 sentences that go with your scenario, in this case, this one. So you're going to literally write, opposite sides are congruent. Opposite sides are congruent. If you even want to underline it just to affirm they are congruent. Your second sentence, it is a parallelogram. That's all you need to write. So we call this a proof, if you will, like a coordinate proof. All the proof, all of the evidence is in your work that you do here. And then you just basically very simply explain why it is a parallelogram, because these opposite sides are congruent. And all this work is the evidence that you need to show that. You don't have to put it all in writing. So that is what you need to do on each problem. I know this is a lot of work, but it's doing the same thing over and over again. So it's really just about practice, practice, practice is what this is about. So the more practice you get with this, I promise you, you will get better and you will get much faster with it. But that is all that is involved in one of these problems. So A bit tedious, but I'd say it's actually not terrible. The problems aren't that bad. All right, that is all for this video. You need to go through and do the other 3 problems. Same way. Find your points. Take the distance formula 4 times. Make sure you're paying attention to which letters you use each time. And then once you figure out if it is or isn't a parallelogram, you'll put your statements down here based upon what I had written in the notes. If you have any additional questions over this, feel free to reach out to me either via email or come ask me in person. Otherwise, I will see you guys later. Bye.